All right, so today I get the privilege of sitting with Rigo Roche, who is a data scientist. So we're gonna learn a little bit about his background and his experience when looking for a new position. And Rigo is what I would call a gold candidate. And so what that means is he has a lot of great experience. The market, when he gets out there, a lot of hiring managers are going to be interested in his profile. So I want to talk to you and have you hear from him himself about what it takes to land a top candidate. So Rigo, if you could give us an introduction about who you are and your background so we can know who we're talking to today.
Sure. Hi everybody, my name is Rigo Roche. All opinions, views, and other information that is done in this interview, whether expressed by me or anyone else, are that opinion of myself. I do not represent any corporation, company, or entity that is related to me professionally or otherwise. These are just my views, my opinion, and my experience, and they're solely mine. My background, I have a master's in biomedical instrumentation, and I have another master's in electrical engineering. And I've been 6 years in industry working for government and the defense industry. And then I also have a bachelor's in biomedical instrumentation. And I started working as what is called now a data scientist after my master's, my second master's in electrical, because I discovered that at that time it was called inferential statistics, which now is called machine learning, through creating filters and designing digital signal processing applications. And then from then on, I just fell in love, and I haven't stopped since. So
Yeah, that's awesome. So I guess when did you get the official title of data scientist?
I don't know. I actually my titles are so weird. I don't think I guess the first time that I used data that was sitting on a hard drive nobody had used for many years to do something useful.
Yeah.
Like it was just there, nobody knew what to do with it. And like, I think we might be able to extract something useful out of it.
Right.
And it worked. And then I guess I became a data scientist for them, I guess. But the thing is that data science in itself, I think, is so broad that you don't really have to have a specific, given the title. Like if you Google, data scientist job or data scientist this or that, it's more about what your skills you have. Because I could be a data scientist that only does Tableau or Python, yet there's other people that are data scientists and they specialize in C++ and web applications and cloud computing, things like that. Yet they're both doing things with data and science.
Right.
So I think in my case it was basically doing that. Just I got a pile of data, somebody needs to do something useful with it, it's just sitting there. That just happened to be me.
And what area would you say is like your expertise within the field of data science?
So in my case, what I do best, so as far as my career goes, is the design of the algorithms that go behind an application. So if you have a problem that so far you cannot find a closed loop solution or some sort of function that represents your problem, then you come to someone like me and then we design a mathematical implementation of whether it be machine learning, some sort of a more mealy machine, like a state machine type of solution, and then implement a combination of that. It's never just one thing, at least for the things that I've done. Sometimes it is. And then that's pretty much it. I specialize on the design and implementation of unique solutions for the problems that you cannot necessarily quantify or have a closed loop solution for right now.
So maybe if you could talk a little bit about some of the data that you worked with before, and obviously I know you won't be able to disclose everything, but some of the problems that you've been able to solve through the work that you've been able to do.
So one of the biggest things we had was we had a data lake of basically what different communication parameters throughout many years. What communication parameters, I mean how two things will communicate with one another, not necessarily cell phone, but in other mediums like space, etc. And there was a lot of information on that because basically you have logs that record all that. And that is very unstructured because you have legacy systems that were implemented 20 years ago, and then you have the ones that were launched last year, and they're all talking to one another. So what you can do with that data is that you can grab it and create like a Markov decision process with several neural networks inside it that give you predictability as to what it is that you're gonna be doing in the future based on what you've done in the past. Not only that, but it also gives you the ability to counter transients, things that you have not seen that could happen, which without such a solution you would just hope for the best. Versus if you have a machine learning system or a combination of systems that can give you, hey, I think that based on my understanding of the data that I have, in the next 5 seconds you're going to drop your link. So I would recommend not sending a command to your satellite at this point, wait, and then send it later. So that data was very highly unstructured. It did not follow any sort of standard. It was not SQL. It was just a bunch of log files and different formats, binaries sometimes that you had to decode into something readable. That's the biggest one. I've dealt with other people.
How long did that take you to be able to?
It wasn't a single person effort. Like we had a team of people, but we did have to. The biggest challenge was collecting the data. It was getting all the information from the different sources and collecting them and putting them in a way that we can actually manipulate it so that we can test it in simulation. Basically the pre-processing. So pre-processing is always about 80% of the work. And especially if you have a good design. So good design is like 10% at the beginning to make sure that you understand what you need to do. It gets better with experience because you just copy yourself. You're like, oh, well, this worked last time, so let's try that first. And then after that, you do pre-processing to match what that design is. And then after that, you basically do your hyperparameter tuning and all your grid search and all that to make sure that your model is verifiable. And then after that, you go and then you test it, and which you do your validation. So like 3 years maybe. We did some experiments. It was a team of people. I just worked on the design of the algorithm itself. So it's more like you have a brain and then you have a body. My job was to create part of the brain that would make the decisions. And then you have other people that do the integration to the actual system itself. So my biggest thing was creating that interface, some sort of I/O test bench that would emulate that peripheral environment in which the model needs to be deployed. And then that was hard too, because you had to understand not only the machine learning side and the what is called data science side, I guess, but you also have to understand the medium in which your model will be behaving. In my case, at that time, was communication systems for space applications.
Yeah, awesome. Any kind of other interesting problems that you want to share with us about, should I say, share with us about you've been able to solve within one of the organizations that you've been with?
So a lot of organizational problems that happened, it comes in a lack of understanding on how data is ingested by models. So if I have a model that is a neural network based type system versus I have an unsupervised problem that I have to do clustering or something like that to figure out, because I don't even know what my data looks like. Those two things are not, you don't prep your data the same way. And there is no one solution fits all type of thing. That doesn't exist, at least in what I've had to do. But there are some good guidelines. So I think that the biggest thing is the creation of databases that are already, for example, one-hot encoded with their class labels. So when you have all this data saved in your hard drive, you can create some sort of pre-processing class that you can instantiate that gets your data and it sets it for you so that you can just load it as a pickle file or some sort of binary like a HD5 or something that is already one-hot encoded. So you don't have to go in and then read 85 terabytes of data and say like, well, what was that class? Was that class 1 or class 7? I don't remember. Let me look at the log file. Oh, the log file is in like 18 substructures. It's like file 1, date 4, hour 7, minute 2, second 3. Okay. And so that type of log structure and understanding that has to be one-hot encoded or it has to be structured in a way that it could be ingested by the model is difficult to understand at the beginning. Because most people, I was one of them, thought, oh, it's a model, I could just do like a little wrapper class that fits that model, boom. Then when you go and you try to scale that and you have to change the model, then you realize, oh, you have a dimensionality problem. For example, in Keras, you have to add the batch dimension, right? And you didn't think about batching at the beginning because you have like 10 samples, but now you have 100,000 or 10 million or 100 million. And then you're like, oh, wait, now I have to batch it properly. So that kind of thing was difficult at the beginning, and it's not thought about. That's why I think that the design of what you want to do ahead of time is very important, so that you can pre-process your data in a way that it matches your design. But when you do that over and over again, you realize that you can create tools that are your cheat sheet tools that you do all the time, and then you can instantiate those cheat sheet tools and basically create databases that are readable by multiple models. And as you develop them in the future, you could still use the same thing. But most people don't understand the value of that, and it also saves you a lot of time when you try to redo it again.
Right. So were you able to implement that system in your last position?
So what we did is we implemented like some sort of class structure, and then we implemented. It was several projects because we touch every different parts of every different. So you touch the network side, you touch the link side, you touch the system-wide side. So what we did is we created like a class structure that does data pre-processing for the different points of it, and it was implementable to a point because there were some things that we cannot have control over. So we can't control the entire network, for example. We don't have the ability to do that because as a research environment, you're limited because it's research, right? You really haven't proven that it works fully yet, even though we've tested it with ISS and stuff like that. So I at least the foundation is set for the future.
Right.
Depending on how useful that is, it will be so. But I use it all the time, and my people, I have had, like the people that used to work with me have used it as well.
Yeah.
We did use it for the Markov decision process. We had a hidden Markov model that we created for creating, basically finding out what the automatic features of a data set were with some help. And we used it for that. We also used it for the clustering, the way in which we tried to, remember I told you that we had like a huge database that we hadn't used for a while. And then we had to do some cluster analysis first to figure out what features of the database were interesting to us. We used it for that. That was a base class that we instantiated to format that in a way that the clustering algorithm will understand. And then we use that same formatted data to implement the other stuff.
Awesome. Well, so as you can tell, Rigo definitely knows what he's talking about, and you can see exactly why I would call him a gold candidate. And so I want to kind of jump into what your experience was like when you decided to make a change to a new organization. So I guess maybe first tell me, where did you start when you were like, okay, I'm ready for the next step in my career? Where did you begin looking for a new position?
So there were several factors. I was really happy where I was, but the thing is that my family was all here in Florida, so I decided to change so that we can. Originally, I wanted to do it internally, but that was not possible. So at least not in preserving the kind of work that I like to do. Right. I would have to change significantly, like go into more of a process or management type thing, which is fine. I don't mind technical management, but the full-on management in which I'm doing Excel sheets and PowerPoints all day, it's just something I don't want to do right now.
Yeah.
Nothing wrong with that. It's just not for me right now. So I decided that it was time for me to start looking outside of the organization, and then I did. And surprisingly, there was a lot of people that were interested in the kind of work that I had to do, and that's it. That's what made my decision. My decision was I wanted to be with my family. I didn't want to travel. I had to travel almost every month.
Right.
I don't know if you recall when you and I were talking. It's like, what city are you on now?
I know. So, never knew where you were.
Yeah. So I that's nice at the beginning, but once you have a family and you have a small child and things like that, life changes.
Yeah. So where did you begin when you were like ready to make the move? How did you start looking for a new position?
So the first thing I did is I reached out to recruiters or people that I knew on the places that I was targeting, and LinkedIn helped a lot because I just put that I'm open to kind of like suggestions or whatever
Yeah.
they call it. I'm not sure.
Yeah.
I'm sorry, LinkedIn.
Open to new opportunities.
Open to new opportunities. Thank
so when
you.
you're looking, turn that on.
There you go. So I turned that on.
And then what happened?
If I could remember what it was called.
How many messages did you get?
And then I got a lot of messages. Some of them were really far off. Really far off. I don't think that they read, I think they read the summary and then they sent me a message after reading the summary. So I was like, come on, just like one more paragraph. Read one more paragraph on the bottom. It's not that hard. You just have to scroll once.
Yeah.
You know? So it was funny. But it was interesting. It was a very tumultuous thing. But you made it a lot better. So
Oh, thank you.
Yeah.
Which is through, I guess, LinkedIn. I sent you a targeted message. I don't know if you recall, but do you remember what made you respond to my message?
I think it was the subject line and also because of the description. The description was very in line to what I was looking for, and also it was in the area. So it's like, I guess I had a nerdy way. I had like a little collaborative filter. So like if the description matches and the subject line matches and the area, the geographical area matches, and then it's more or less within the realm of what I would consider, then it's a yes. If I have any of those 4 points missing, then it's a no.
Okay.
And then yours was yes. So
Check the boxes.
Check the boxes.
I'll
I'm
respond
like,
to her.
hi. That's what happened pretty much. It was pretty straightforward in that sense. But yeah, the SNR is the signal to noise ratio is really, really low. There's a lot of noise.
Right. So do you remember about how many messages you got in that period when you had your...
More than 20 for sure.
Okay.
More than 20.
Yeah.
That was per week.
Yes.
Yeah. So like total, like more than 100.
Mm-hmm.
Yeah.
And
they were long. Some of them were really long. I like the fact that yours was short.
to the point,
So it's
you
to
know?
the point. It's like I have this. It's the description. Boom, and that's great. That's because I mean, in looking for a job is a full-time job.
Yes.
And then, especially if you want to do like a real job matching, like you want to end up somewhere that you're really happy with. It's not like, oh, I'm just gonna go to whoever pays me the most, even though I have to, get a cot and sleep there.
Right.
Yeah, and it sucks, and the environment of the company is like very aggressive, and it's not collaborative, and that's not where you want to be. Even if you make millions of dollars, that's not where you want to be, because you only have one life, and if you spend your life in work, is where you spend most of the time.
Yeah.
Like 80-90% of your time is going to be at work. So if you're just not happy doing whatever it is you're doing, even though you make a lot of money, it doesn't matter, because by the time you're 50, you're going to be really angry with the world.
Right.
Yeah.
It's
Because you
important.
spend 30 years just angry constantly, so you can't get out of that. It's hard.
Yeah.
As long as the money is reasonable, I will choose happiness over pay. any day.
Right. Yeah.
That's just personal. If you're a young kid that doesn't have kids, and you can live in your Tesla, then go for it. Make millions.
Yeah, I mean, you got to understand everyone's needs and what they're looking for at that point in their career and life. So I guess how many, if you can recall, about companies were you interviewing with and were interested in?
I'm not gonna mention names, but
Yeah.
it was it's like at least 12.
Okay.
At least 12.
Yeah.
Which was crazy, because sometimes I would have to read the person's name before I called them, because I would not recall what the job was about, that specific one.
Right.
Because it's all machine learning, but you could apply machine learning to drones, or you could apply it to like things like autonomous farming equipment. You don't want to be talking about autonomous farming equipment to the drone person.
Right.
Right?
Probably won't get to the second interview.
It's like, I think you think I'm somebody else. So I had to get like little tags, like, so you can put tags in Linux. There's like a little thing that you could write. You can write your little cheat sheet man pages, and then I did that for a lot of the people, and that's I had like 3 or 4 people that I remember. I remember you. I remember the other 2 people, but most of the people it's not possible, because I have my real job too.
Yeah.
Like I have to get my real work finished. And